Hi Satya, can you hear me?
Yes, good afternoon.
Good afternoon. We can wait for a couple of more minutes and then start with the session. I'm not planning to discuss anything specific because I think more or less, not more or less, I gave the whole summary in the last live session. So only if you have any specific questions related to your quiz, we can discuss in this live session. Okay. So I'd like to deal with each of you individually. So yeah, I'm not going to discuss anything in common because everything that's part of quiz 2 is already discussed in the last week live session. So if you have any specific questions, I'll deal with each of you individually. Other than that, I don't have any plans of taking, separate content session today. Okay. So yeah, I hope my screen is visible. I am displaying the topics. If you have any questions, I mean, each of you, if you have any specific questions, we can talk one to one. Okay. Yeah, I am here today for an hour. So it depends on the number of questions you ask me. So if you have any questions, I am here for more time. Yeah. So
Ma'am,
yes.
so good evening, ma'am. I have one doubt on GA7.
Graded assignment 7, right?
Yes, ma'am.
Let me open that. Mm, tell me.
Question 9,
Mm.
um, will there be any minus symbol on the power?
Yes. There should be a minus symbol. Thanks for Gayatri also kind of pointed this out. Yeah, there's a minus symbol missing. Correct.
And the
Yes.
next question also, I think there was a problem.
Next, yes. Next question also. I think the answer is B, right?
Yeah, the same
Yeah,
minus.
yeah. Minus symbol is missing. True. We will do a re-verification for this. Okay.
Yes, ma'am.
But your marks should have been released, right?
Not yet.
Okay, then we will do the re-verification. Okay.
Okay, ma'am.
Yes.
Uh, will there be any lengthy questions in the quiz?
No.
Okay.
Yeah, only if you have any specific questions, I'm going to take today's live session. If you don't have any specific questions, yeah, just utilize this 2 hours to practice for your quiz, okay? And also
That's
next week, week 9 live sessions will be taken by another course instructor. So next week, 2 sessions or 1 session maybe, not really sure. So there is another course instructor like me for this course, Mr. Tony. Okay, so he will be taking the next week live sessions regarding week 9. Okay, so yeah. Someone was asking me something. Tell me.
I have a doubt in practice assignment 6, question 1.
Practice assignment 6, question 1. Yes, what is your question? So
Please
let me
solve this
write
question.
so f of t is given as u of minus t, and g of t is given as 2 times u of t minus u of t minus 1. So your h of t is given as the convolution between these two functions. Now you're supposed to find h of t for t less than 0. Okay, so this is the question that was given to you. So how do you solve this question? So anyone, like, do you want to give it a try? I hope others would have solved this, right? So any thoughts on how I can proceed? So h of t, let's just use the simple tools that we learned, okay? So this is u of minus t convolution with 2 times u of t minus 2 times u of t minus 1, which is u of minus t convolution 2 times u of t minus u of minus t convolution 2 times u of t minus 1, right? Because convolution is distributed. This is again is 2 times u of minus t. Constant do not affect the convolution, hence this is just u of minus t convolution u of t minus 1, right? So this is one way of doing this. So you can evaluate the convolutions separately and then see, like, try to find the overall signal and see like what it will be for uh, you know uh, t less than 0. So that is one way of solving. Or other way is u of t is this, and u of t minus 1 is this. So this is u of t minus 1, and the blue line is u of t. When I subtract these two, what will I get? I will get t. This is 2, 0, 1. This is just g of t. Okay, so this is your g of t. So this is how your g of t is defined. Now you have to convolute between f of t and g of t. So what will that be? That is minus infinity to infinity g of tau f of t minus tau d tau. So f of t is u of minus t. F of t minus tau is u of minus t minus tau. And as you could see, g of tau goes from 0 to 1, 2 times f of this is minus t minus tau d tau. Okay. So what happens to u of minus t minus tau? U of minus t minus tau is 1 when minus t minus tau is greater than 0, 0 otherwise. So this implies minus t is greater than tau or t is less than minus tau. So for all t less than minus tau, it is 1, or otherwise this is 0, right? So this is your y of t. Am I missing something in what is solved here? Did I miss something? Did I make some mistake somewhere? Let me evaluate with the other part. I think I'm missing out something here. Sorry, this is tau should be, this is tau less than minus t. So for tau less than minus t, this is 1. So I think I'm missing something. Did any of you guys attempt this question? Hello?
Yes, ma'am.
Yes, but I also do with the graphs with the use of the first.
To do with graphs, but even this should work, right? So let me just revisit the question once. Okay, let me try to evaluate what happens to u of minus t and u of t when t is less than 0. So when t is less than 0, so this is minus infinity So this is, let me call it f1 of t. F1 of t is minus infinity to infinity minus tau u of t minus tau d tau. So t is less than 0. So what happens to this? So u of tau, u of minus tau is, for simplicity, let's take t is equal to minus 1. Okay. So u of minus tau is 0 for all tau greater than 0 and is 1 for all tau less than or equal to 0. So this would just become minus infinity to 0, 1 times u of minus 1 minus tau d tau. U of minus 1 minus tau just becomes 1 when minus 1 minus tau is greater than 0, which is otherwise for tau less than minus 1, 0 otherwise. So for all tau less than minus 1, for all tau less than minus 1, this is 1. So this is minus infinity to minus 1. This is where I'm little confused. So this should be the other way around. Am I missing out something? Is the question for t less than 0 or t greater than 0? So they're asking for t less than 0.
4 less than 0.
Less than equal to 0.
Yeah, so this is less than 0. The steps seem correct, right? Did I miss something? So u of minus tau is just this. Or if I go the other way, so this is minus infinity to infinity u of tau, u of minus t minus tau d tau. Let me take t to be minus 1. So this is 0 to infinity 1, u of 1 minus tau d tau. U of 1 minus tau is 1 when we have 1 minus tau to be greater than 0, which is 1 greater than tau, 0 otherwise. I think this way this is the same to work. So this is d tau, which is 1. So this way this is working. So if you try to evaluate u of t with u of minus t, so this is minus infinity to infinity u of tau, u of minus t minus tau d tau. So this is minus, so 0 to infinity u of minus t minus tau d tau, right? Because u of tau, it's just the definition of u of tau, and this part is equal to 1 if minus t minus tau is greater than 0. Otherwise minus t, so tau is less than minus t. Okay, so since t is negative, so this is integral 0 till minus t 1 d tau, which is just, I think, minus t for now. And then let's try to evaluate the other part. Other part says this. So u of minus t star u of t minus 1, which is integral minus infinity to infinity u of tau minus 1, u of minus t minus tau d tau. So this is integral minus infinity to infinity or integral 1 to infinity u of minus t minus tau d tau, and this is again 1 till minus t 1 d tau, which is nothing but minus t minus 1, right? So overall what we have is in the question, so that is u of minus t convolution u of t minus 2 times, okay, sorry, 2 times this minus 2 times u of minus t convolution u of t minus 1. So we just saw this is 2 times minus t minus this is 2 times minus t minus 1, which is just 2. So I think something I'm missing in the other way, like technically both should be equal. Maybe I'm doing something wrong in the other way, but the overall idea is this, okay? So you can solve this like this. So f of t is given as u of minus t, and g of t is given as 2 times u of t minus 2 times u of t minus 1. So you're supposed to find f of t convoluted g of t, but the distributive property this is same as 2 times u of minus t convoluted with u of t minus 2 times u of minus t convoluted with u of t minus 1. So let's try to evaluate each of these terms separately. When we evaluate u of minus t with u of t, it is minus infinity to infinity u of t, u of tau, u of minus t minus tau d tau. Remember, we are looking for t less than 0. So this is minus infinity, so this is 0 to infinity u of minus t minus t minus tau d tau, because this is defined as 1 when tau is greater than 0, 0 when tau is less than 0. And now this is defined as 1 when tau is less than minus t, 0 when tau is greater than minus t. And since our t is negative, okay, minus t will be lying on the positive axis, hence this integration would become 0 to minus t 1 d tau, which is nothing but minus t. Likewise, when you evaluate u of minus t with u of t minus 1, what you get is minus t minus 1, okay? And yeah, so and when you try to just use plug them in this part, what you get to see is y of t is 2 times minus t minus 2 times minus t minus 1, which is just 2 when t is less than 0. So that's the idea. Other ways should also work because convolution is associative. But I think I'm missing out some terms like which I couldn't see right away. But yeah, this is it. Is that okay, Satyam?
Yes, then, but I have a confusion. Where you convoluted u of minus t and ut,
Mm.
then and then how you write integral u of minus t minus tau d tau?
Oh, you mean this? So this is just the definition of convolution, right? So let me call this as f1 of t and this as g1 of t. Okay. And what is convolution between f1 of t and g1 of t? This is integral minus infinity to infinity f1 of tau g1 of t minus tau d tau, correct? Yeah.
Yes, ma'am.
And now what is, so f1 of t is defined as u of minus t, or this is also same as uh, or let me use, okay, this is also same as integral minus infinity to infinity g1 of tau f1 of t minus tau d tau, correct? Because convolution is associated. So your f1 of t is u of minus t and g1 of t is u of t. So what would be your g1 of tau? Just replace t with tau, which is u of tau. What is f1 of t minus tau? f1 of t minus tau is u of, so I see your confusion. So your confusion is uh, so this is the time shifted version of the original signal, right? Yeah. So you're shifting this by minus tau in the original signal. So in your original signal is minus t. When you shift it in time, it would be u of minus t minus tau. I get your confusion. Won't f1 of t minus tau would be u of uh, minus of t minus tau. So that would be u of minus t plus tau. So that was your confusion, right? Uh,
Yes,
so,
ma'am.
so I'm trying to understand. So if that is your confusion, so this is it. So this is the time shifted version of the original signal, and the original signal is u of minus t, and the time shifted version would be u of minus t minus tau. That's how we are writing this u of minus t minus tau. Is that okay?
Yes, ma'am.
Okay.
Can you place your iPad in the credential?
What?
Your iPad in landscape.
Sorry, I didn't get you.
Ma'am, please place your tablet in landscape mode.
Oh, like that. Okay.
Yeah. Yeah, now it's good. Thank you.
Okay.
Ma'am,
Yes.
in the same practice assignment,
Mm.
question 7 and 8.
Question 7 and 8. Okay. So the questions, yes. So seventh question says you are given h of t, which is e power minus t by 2 u of t.
So, what's the easier way to prove it's linear?
So you just have to go by the logic. So there is, and let me think about it. I think there is some sort of, Yeah, I guess there is some sort of confusion in the question here. The input output relationship is not given properly. So there's some sort of, so there's something missing in this question. So the question is not fully complete. Yeah, maybe I should also make note of this. So this is practice assignment, right?
Yes,
All
ma'am.
right. Yeah, there is some sort of incompleteness to this question. The reason I'll tell you. So you are given some system with the impulse response as e power minus t by 2 u of t. Okay. So how do you check for linearity? The check for linearity is when you pass x1 of t into the system, along with this impulse response, you get some output y1 of t. Likewise, when you pass x2 of t, you get some output y2 of t, right? And when you pass some linear combination of these two inputs, that should produce you the outputs, linear combination of the outputs. So this is how you check for linearity. What
Yes,
we
ma'am.
know is for an LTI system, the output is the convolution of input along with the impulse function. But we don't know like if the system is linear. So in order for us to verify if the system is linear, some relationship how the transformation is actually happening should have been given in the question, which is missing here. You understood what I mean, right? So there is some
Yes,
level
ma'am.
of incompleteness to this question. So the question is not fully specified. So you can ignore this question for now. So you can also let the other students know. Practice assignment 6, 7th question, please ignore for now. But for the time invariance, you can maybe,
Ma'am,
yes, yes.
one thing is if impulse response is defined, then that system is linear time invariant, right? Only for
Not
defining
really, not
systems,
really, not really, not really.
but
So,
impulse
uh,
response is not defined for other systems, no?
I mean, to any particular system, you can actually, come up with the response of the system when you pass the impulse function.
Okay.
When you pass impulse function, you might get some output. So that is known as the impulse response. The definition of impulse response is when you pass an impulse function into the system, the response that you get out of the system is the impulse response. But for LTI system, you can specifically find this impulse response because the output is the convolution of the input times the transformation that is happening. And also there are other reasons in your next week 9 lectures you will get to see like how you can actually find the impulse response of an LTI system because of this convolution operation. So this happens only for an LTI system. But for any other system, if it is not LTI also, when you pass the impulse as the input to the system, whatever the output you receive is the impulse response, but you cannot characterize it specifically. So, because of that reason, there is some level of incompleteness to the question. Otherwise, the question itself doesn't make sense, right? So, when there is an impulse response that was given, like it's a direct answer that this is an S. So, but yeah, we may have to think about this. Questions 7 and 8, they are incomplete at this point, but we may redefine these questions and provide them in your next practice assignments, okay? So, you can wait for that. All right,
Okay.
for now, please ignore those two questions.
And ma'am, So the convolution operation can be done using Fourier coefficients, right?
Fourier coefficients. Oh, you no. The multiplication of two signals can be done using the Fourier coefficients.
Yes, ma'am, could you please show one example if possible?
Uh, for finding the multiplication using Fourier coefficients,
Yeah, yes.
let me
This from
open
the
your
page.
lecture notes so that I'll be,
Yes.
okay, suppose theory is this. Suppose you are given two signals x1 of t and x2 of t. Okay. Uh,
Yes.
suppose the time periods, those two should be periodic signals for the Fourier series to exist in the first place. So suppose let the Fourier series, suppose the period of these two signals be t1, t2, and you assume t1 to be equal to t2, which is equal to t. Okay. In such a case, x1 of t can be written as sum over k from minus infinity to infinity, ak e power minus j k omega naught t. Likewise, I mean, in order for you to show the example, so this is just the theory behind, but I don't want to go with the example. The reason I'll tell you at the end. So this can be written as n from minus infinity to infinity, bn e power minus jn omega naught t. So because these two are periodic signals, you can write them as sum of the exponential signals where ak's are the Fourier coefficients of x1 of t and bn's are the Fourier coefficients of x2 of t. So
Ma'am,
x1 of t, yes.
so the will there be a minus symbol on power?
So yeah, sorry. So thank you. So yeah, x1 of t has Fourier coefficients ak for all k belongs to integers, right? And x2 of t has Fourier coefficients bn where n belongs to again integers. Example, let your ak's be 1, 1, 0, 1 by 2, zeros everywhere. Let this be your set of ak's, this being 0, as in this corresponds to a1, this corresponds to a2, this corresponds to a minus 1, this corresponds to a minus 2, and so on. Okay.
Yes, ma'am.
Let this be 2, 3, 1, 0, 1, 5 and zeros everywhere. Let this corresponds to my 0. Let this be A1 until A5. This be A minus 1. Sorry, B. Okay. So these are my two sequences of discrete values. Yeah. So they are defined in the discrete time, not in the continuous time. Okay. So now x1 of t multiplied with x2 of t can be written as some z coef from minus infinity to infinity. Okay. Cz e power j z omega naught t, where Cz is the convolution of these two sequences. Convolution of the sequence AK with the sequence Bn. So when you convolute two discrete sequences, you will get another sequence, okay, uh, which also goes from minus infinity to infinity. I'll leave you just with the definition of the discrete convolution, but that is not part of this course, so you don't need to worry. So any sequence AK with Bn, let this be, or maybe Xn convoluted with Hn, where n is the discrete time. In this case, in case of AK, let's define An. Okay, so An is what? 0 when n is 0, 1 by 2 when n is 1, 1 when n is minus 1, 1 when n is minus 2, 0 elsewhere. Likewise, let's define b of n corresponding to the sequence Bn. So that is 3 when n is 0, 2 when n is minus 1, 1 when n is 1, 0, and so on, 5, 0 when n is 5, and so on, 0 elsewhere. Okay. So for these two sequences, one can find the discrete convolution by applying k1 from minus infinity to infinity, x of k1, h of n minus k1. So this would be the sequence C of n. Okay. So this sequence corresponding to C of n, which otherwise can also be represented as Cn or Cz, where z or n varies from minus infinity to infinity. They are all discrete values. Okay, that gives you the final sequence for the multiplication of two signals. But yeah, as said, you don't need to worry about this set of things because this includes the discrete time convolution of two signals, which is not part of this course. Okay, but this is the overall theory behind it. I hope I answered your question.
Yeah, yes, ma'am. And ma'am, what if the time period is different?
When the time period is different, then this cannot be the trick. So these are
Okay.
certain properties. Only when they have the same time period, this is true. But for a different time period, you may have to multiply these two signals appropriately. But when they have the same time period, this is what it happens. So this is just the property of convolution. Okay.
Yes, ma'am.
Yeah. All right.
Right.
Yes.
I have another doubt in graded assignment 8. question 5 and 7.
Graded assignment 8. Let me open the assignment. Graded assignment 8. Which question?
5 and 7.
Okay. Uh, so if you, yeah, so this is something. So are the solutions out? I mean, is the deadline for the assignment got over?
Yes,
Yes,
ma'am.
ma'am.
Okay. So week 8, question 5. So you have to find. So the question is x of t is mod sine phi t. And I think in one of our earlier assignments, we did the time period for this particular fundamental time period for this particular signal is 1. Reason also, I think, like we told, usually for sine pi t, the fundamental time period would be 2. But since this is mod, the signal keeps repeating for every one period. You can think about it. So the fundamental time period is 1. Now, fifth question is asking you to find AK for k not equal to 0. What is AK? AK is 1 by T naught, which is 1, integral minus half to half sine pi t dt. Since this is a periodic signal, I can also write this as integral 0 to 1, because mod sine pi t dt. The reason why I did this is, since this is a periodic signal, when you try to absolutely integrate it between minus half to half, or when you try to absolutely integrate it between 0 to 1, it actually yields the same value. Since this is a periodic signal, it doesn't matter. You just have to absolutely integrate within one period. So it doesn't matter where exactly you're integrating it from, but you should be uh, integrating. So the integration should, the average should the average should be taken with respect to one period. So I'm choosing my one period to be 0 to 1. Okay. And when you do this from 0 to 1, the signal behavior is exactly same as your sine signal. No change.
Ma'am,
Yeah.
why we are not including e power minus j, those things?
Oh, sorry, that is also there. Thanks for reminding me. That is important. So this is e power minus j k omega naught t dt, where my omega naught is 2 pi by t naught, which is equal to 2 pi. So this is e power minus j k omega naught t dt, or minus j k omega naught t dt. Okay. So from here onwards, you just have to do the integration. So this can be written as e power j pi t minus e power minus j pi t by 2j times e power minus j k 2 pi t dt. So when you try to solve this integration, what you get at the end is 2 by 5 times 1 minus 4k square. This is what you end up with. So you just have to solve this integration. So I hope at least fifth question is clear.
Yes, ma'am.
Okay. So now moving to the seventh question. So this is where like we have clearly mentioned that you have to use the Parseval's theorem. So if you see in your sixth question, you calculated the power without using any of those techniques, and the power of the signal can be easily evaluated like how we did before, and it can be proven to be equal to 1 by 2. Why? So the power is the average energy, which is 1 over T from so average energy within one period. So when I say one period, it could be either from minus T by 2 to T by 2, or it can also be from 1 over T 0 to T mod x of T square dt. And as said, in the interval, so T is 1, in the interval 0 to 1, our given signal behaves exactly as the sine signal. So this is integral 0 to T sine square of T dt. So you can try to evaluate this integration when T equal to 1, and you can see that the power of the signal is 1 by 2, just by using our formulas that we learned from our earlier lectures. Okay. Now in this week we have learned something new. What is the new thing? That Parseval's theorem states that the power of a periodic signal is given by the sum of all Fourier coefficients, right? So implies 1 over 2 is equal to, as you could see, AK is equal to A minus K for the given problem, because you have a K square factor, so it doesn't actually affect. For the negative case also, AKs would be the same. Hence I can write this summation as 2 times K from 0 to infinity mod, or A0 plus 2 times K from minus 1, K from 1 to infinity mod AK square. Correct? Because of you know because of the functionality of the AKs, I can write like this. And from your earlier problems, I think fourth problem, you found A0 to be 2 by pi. Correct? So
Yes, ma'am.
substituting that along with whatever we have, so we have AKs as 2 by pi times 1 minus 4K square. So there is a summation in front, summation K from 1 to infinity whole square. Alright. So this is equal to 1 by 2, which in other words, 1 by 2 minus 2 by 5, so 2 by 2 is just sum over K from 1 to infinity 4 by pi times 1 minus 4 square whole square. So this is what it is. So this is just simply 1 by 4 minus 1 by pi. Oh, sorry, it should be A0 square, right? One by 4 minus 2 by pi square. So this is what it is. So this is how you need to solve such problems. At least in your assignment, like we have clearly mentioned that using Parseval's theorem, and from the above results, please find this. But when you write any competitive exams, they won't even give such hints or clear definitions. You will be given something like this, and you will be asked to find the sum. You have to be used with all this. For your information, this is one of the gate questions. Okay. But yeah, clear mentioning everywhere like use this, and all won't be given. just the signal will be given. For such a signal, using that signal you have to find this sum, so you have to try out all your ways to figure this out. So this is how it is. So you have to relate this with the Parseval's theorem and go with it. Okay.
How would you write A naught square to the signal?
A naught square, that's from the definition, right? So uh, so P is given as sum over k from minus infinity to infinity mod ak square, which is just a is mod a0 square plus mod a1 square plus mod a2 square plus and so on. And on the negative axis, we have mod a minus 1 square plus mod a minus 2 square plus and so on. And this is just mod a0 square. And since a minus 1 and a1 are equal, a2 and a minus 2 are equal, I can just write this as plus 2 times mod a1 square plus mod a2 square plus and so on, which is mod a0 square plus 2 times sum over k from 1 to infinity mod ak square. Is that clear? It's just straightforward, right?
Yes. Okay.
Yeah. Any other questions?
Ma'am,
Yes.
so here this 2 times k is equal to 1 to infinity, that sigma term, it's not true for every case, right?
No. This is because for this particular
It is
problem,
symmetric.
yeah, they are symmetric. Not always.
Yes. And ma'am, is it possible to find whether a naught is 0 or not just by looking at the function expression?
This is
Because
something
in
that
use,
we discussed, I think, in one of our earlier lectures. If the function is an odd function, then your DC component might be 0.
okay. If it is odd, then it will be 0, is it ma'am, or the other way?
Yes. If it is an odd function. If it is an odd
Yes.
function, then a naught is 0 because you are trying to average over one time period. And in one time period, the function is odd. And when you average it, the average value is 0, right?
Yeah, yes, ma'am. Yes. Okay. Yes, ma'am.
Excuse me.
Yes.
Week 6 practice assignment, question number 9. Can you please explain?
Um, this is straightforward, right? So, what is your doubt? So, week 6, we practice assignment question 9. So, the impulse response of an LTI system is given something like this. So, the given system is LTI, and the input to the system is U of t. You're supposed to find the output. What is the output? X of t convoluted with h of t, correct? So this is integral minus infinity to infinity u of t. I can do it the other way. So this is also same as h of t convoluted with x of t, which is nothing but e power minus t by 2 u of t, u of t minus tau d tau. So u of tau, right? Which implies integral 0 to infinity e power minus tau by 2 u of t minus tau d tau. And u of t minus tau is 1 when t is greater than tau, right? So yeah, so we just have to put that in here. So okay, I'm missing out something. So u of t minus tau is 1 when t minus, oh sorry, so this is something that we are looking in terms of tau. So this is when tau is less than t. So this is 0 to t e power minus tau by times 1 d tau. And what is this? Minus 1 by 2 e power minus t minus 1. So which is 1 by 2, 1 minus e power minus t by 2, right? So this is just direct, right? So yeah, so this is when t is greater than 0. When t is less than 0, this integration doesn't make any sense. So this whole thing is when t is greater than 0. For t less than 0, this integration itself won't be existing, because what do you mean by integrating from 0 to the negative value? So that itself is not there. Also, the other values also won't exist, because u of t minus tau exists only when t is greater than tau, or tau is less than t. So when t is less than 0, u of t minus tau itself is not defined. So hence this whole thing is 1 over 2, 1 minus e power minus t by 2 u of t. Is that okay? This is pretty straightforward, right? Like convolution. It's just convolution, there's nothing more to this.
But option is 2 into 1 by
What
2.
happened?
In place of 1 by 2, it is 2.
Okay. No. So sorry. This should be 2, because I missed out. So this is so
Yes,
what
ma'am.
is integration e power at? So integration e power at is by a.
Oh, yes, ma'am.
So this is by 1 by 2. So this should be 2. Okay. I missed.
Yes, ma'am. Thanks.
Yeah. Any other questions?
Ma'am,
Mm.
the next question, ma'am, the 10th one. So that's a RAM signal, right? Ma'am?
Mm.
Okay.
It's a RAM signal, but then you guys should be comfortable doing these things. In another 2 days, you guys are having your quiz. So f of t minus
2 days.
t1.
Tomorrow we are having.
Okay, tomorrow. So not even 2 days. Okay,
Yes.
so you guys should be really comfortable with this. This is something we discussed multiple times during those earlier sessions. So I think even while discussing week 6 live sessions, also I discussed more on these things. So this is some h of t minus t1 plus t2, where h of t is the convolution of f of t with g of t. We know that u of t convoluted with u of t is the ramp function r of t. So what should it be when u of t convoluted with t minus 2? It should be r of t minus 2. Just applying this property. Straightforward, right? I mean,
Yes.
complicated questions I can understand, but easier questions you should be in a position to do. Otherwise, yeah, you guys need to prepare hard. Uh,
Ma'am, there was one more question like y of t equal to f of t convolution g of t.
hmm.
How will you express f of t minus t1 convolution g of t minus t2.
Okay, so okay,
We
so
can,
there's a question in your graded assignment, right? To prove this.
yeah,
Uh,
not prove.
did
We have to derive y in terms of t1 and t2. So the answer was y of t minus t1 plus t2.
this is what it is, right? So this is what this
Uh,
property is the question, right? So there's no different from it.
oh, okay. This is slightly
What is difference in this? No, they are the same things.
okay.
Same thing.
So yeah, maybe in your question this is given as y, so it's the same thing. So this is some property that is already discussed in your lecture video. You can go back and refer to that. So there is a specific thing that was proven. Okay, this is already discussed in. So that's why I gave you it as graded assignment problem. This is direct from your class notes. So this is the property of convolution. Yeah, suppose if y of t is the convolution of these two signals, and the convolution of the time shifted versions is y of t minus t1 plus t2. If you want the proof, you can just refer to any textbooks or anything. So this is pretty straightforward. So you just have to consider this as some f1 of t and this as some g1 of t. And what is f1 of t convolution g1 of t? That is f1 of tau g1 of t minus tau d tau. G1 of t minus tau is g of t minus t2 minus tau. F1 of tau is f of tau minus t1. This is from minus infinity to infinity. And you have to, do the change of variables accordingly. And what you get is this. But yeah, these are properties of convolution. So at this point, having your quiz tomorrow, you guys shouldn't be focusing on the proofs. Should be comfortable with applying the techniques. The exam is not descriptive. Yeah. Uh, yeah. If, if you're interested in this, we can do in our later live sessions, but I don't want to waste time in proving this now. Right? So if you have any specific questions, please stay on. Otherwise, please go ahead and start preparing with your quiz. Yeah. This is not a content class today, so please don't waste your time. Only if you have any specific questions, please stay. Otherwise, please go and prepare for your quiz. I was thinking your quiz is on August 7th. For some reason, I'm confused. But it's tomorrow you guys need to be preparing.
Yeah. Madam,
Yes, yes.
can we get the access to the lecture slides?
I already requested this with the professor. Okay, we'll ask the team to upload. Okay.
Ma'am, actually, it will be very helpful for the revision if we can get it.
Okay, sure. Also, please have the practice of writing notes. Okay. So don't depend on the slides. Don't expect something from us. It's always a good habit to take your own notes. Also, since this is an online course, it's always good to have class notes with you. But yeah, anyways, I'll again check with the professor, and if he agrees to it, we'll upload it right away. If he doesn't agree, I'm not sure. Okay, I'll check with him.
Okay. By end of the day, please try to upload if he agrees.
Okay, sure.
Yeah, thank you.
All right. So please go and start preparing for your quiz. I don't want to waste more time on this. All right, okay. Hello.
Yeah, ma'am, sure.
Yes.
Yeah.
Yes,
All
ma'am.
right. So
Thank you,
yeah,
ma'am.
I'll be ending the session.
Okay, thank you, ma'am.
Thank you. Yeah. Thanks. Bye.
Thank you, ma'am.
Yeah.
Thanks.
Thank you, ma'am.
Yeah. Bye.
Ma'am, one question.